Hello YouTube and Professor David Stovell. My name is Gabriel Atienza and I'm here today to show you my final project for programming 1442. So just a brief overview of the application here and the project description. We were required to create an application using a new framework of our choosing. So I chose to use .NET MAUI using the MVVM architecture. And the application I decided to make was a World of Warcraft Priest Companion app. So I'm an avid World of Warcraft player, and so I thought it would be fun to include a little talent calculator for the Priest class, and also have a way to view log data at the click of a button, so that way I can see my standings against players of similar skill. Alright, so let's head on over to the application itself. So you'll see here at the bottom we have three major navigation tabs. We have the home page, which is what you see here, the talent page, which is the talent calculator area, and the log page, which will display all the data that is associated with the Warcraft log API. So let's first head on over to the talents. So you notice there that briefly there was a little loading symbol, and that's because I created a API that stores the talent profile data, just in case I deleted the app and I wanted to maintain my my progress, I guess. But yeah, so essentially what happens is I have a blank profile here right now, but I'm actually able to save my talent selection and talent profile name to the database, that way using my API that I've created. So let's just head on over and we'll do some modifications to some of these talents here. And so it just takes a second for the page to load just because there are so many image assets, but once it's already instantiated, the page load is much quicker. But over here, we have a list of all the different talents available to the Holy specialization. So when we hold and click on the icon here, we see what each of the talents will give you. So this one here increases the critical strike chance of your holy spells by 0%, and that's because it is currently rank 0. But if I add in a point here, you'll see that the number dynamically changes, which is pretty neat. And then once we have reached 5 points in a row, or every cumulative 5 points invested into the specialization, a new row will appear. So pretty cool. Additionally, I've also added logic in here to prevent this talent from being selected if its prerequisite is not at its max rank here. So let me just, I just need to add one more point into this tier. Boom, and beautiful. We can no longer select this talent point because its previous rank is not at the, or its prerequisite talent is not at its max value. And you'll notice here that I had to add in 1 point into the soul warding talent because essentially what had happened is that in order to put talents into these rows, there needed to be a minimum of 10 points in the previous rows. So in order to accommodate that, I just added 1 point here. Additionally, we have a little reset button here, and we're able to quickly reset all the talent values. So I'll just head on over to the discipline and shadow pages. So they are very similar in the setup. However, they have different talents and different values that are unique to each class and specialization. So I'm just going to add in a few here. And we have a total count of all the talents. And what I'm going to go do now is I'm just going to go over here and I'm just going to scroll down to update the profile here. So as you can see, we have 7 points in the discipline tree. So 5 and 2, 7. And then shadow for a total of, looks like 15 here. And so you'll see we have the 7 discipline points and the 15 shadow points. So I'm just going to change this to demo profile. So that way I can show you that when I reload the app, the profile data will save. Awesome, so our update was successful. And what's really neat is that these specific talents will also be populated when the app reloads itself also. So super cool stuff there. So let's head on over to the Warcraft log part of the page. So what I've done here is I've taken a lot of inspiration from the World of Warcraft logs website itself and tried to recreate the app or the user interface using XAML. And so similarly, I've done that with the talent profiles here. So what I'm going to do is I'm just going to scroll down and we're going to load in the API data for the Warcraft logs. And here we're able to see all of my combat parses in comparison to the other priests. So it looks like right now I'm the number 30 priest in the world, which is pretty great. And I have the number 1 parse on this boss XT here, so that's very fun. But what's really interesting is that I've been able to actually dynamically choose the color that this text will be. So what I've done here is actually I've bound the API data to a collection view. And I've attached to this label output here a converter. So based on the binding value sent to the converter, it will display a different color to the user. So pretty neat. And if we look at the bottom here, we can actually also change specializations or metrics. And then we just scroll down to populate that data there. So awesome. All right, so now that we've covered the functionality of the app, let's go take a look at some of the code in the application. So to get started, let's talk about MVVM and the file structure that's required. So MVVM stands for Model, View, View Model. So we have our model folder here. So these are all the classes that encapsulate the data inside of the application. We have our view folder, so this is the XAML or markup pages that display the user interface to the user. And then we have our view model class, which is responsible for maintaining and connecting the data binds to the actual XAML page itself. So in order to use the MVVM architecture in .NET MAUI, we have to do a couple of things. So we need to go to the MAUI program first and register the pages in the builder. So as you can see, I've added the main page view model as a singleton since this is the entry point for the application, and it is also assigned as the where the app shell will be held. And then we have all these other pages throughout the application registered as transient pages. Up here, we have our services, and these services are essentially the API connection points, and we inject all of these things here in the builder using dependency injection. All right, so let's go take a look at the app shell, and I can go over some of the formatting for our navigation bars that you've seen throughout the application here. So as you can see, we have the home, talents, and logs pages. So in order to accomplish or to accommodate this inside of our navigation pane, I've created what's called a tab bar object. And inside of that tab bar object, we have a whole bunch of smaller objects called tabs, or child objects, I should say. So we have the home tab, and that will navigate us to that page there. We have the talents tab with its 3 sub-content pages here. And then, 4 sub-content pages, and then the logs tab. Yeah, so that's all the setup we need on this page to get that going. We also need to head on over to the code behind and actually register the routes in order to actually be able to physically have the app shell go to those locations. So this is a very pivotal step of the process. Alright, so next up, let's talk about some of the models that I've included inside of the project. So we have an enumeration just used for some small logic throughout the application. I have this healing logs object, which is used for parsing the Warcraft logs data into the application. I have this talents class, which is really cool. It's an observable class, and since it inherits from observable, I'm actually able to give it observable properties. And these observable properties actually will be able to trigger on-change events. So using these on-change events, I'm able to go through the code and call these custom methods that I have defined to replace the descriptions, the icons, or I think it's actually mostly just description and icons. depending on the how this class is used in the code behind or the view model. So next up, we have our talent profile and our talent profile DTO. So similarly to the healing logs, this is used to parse the talent profile data into the application. The DTO here is slightly different from the regular talent profile object. So here we have a talent string, whereas in the original object, we actually have an array of integers. So in order to store this data in SQLite, storing it as a string makes it very easy to transfer back and forth. Since SQLite does not support integer arrays or a collection type as a single standing property for storing data in a database. All right, so let's head on over next to some of the services that we have in the application. So, as I said before, these services, they are created as singletons and then injected into each of the pages, meaning that they're shared throughout the application and used only when we need them. So the first one I'll go over is this talent service. So this one here, I actually hard-coded the data so that way the app can be used while there is no internet connection. And I've added a default profile if that case occurs. So that way we don't have to worry about having a profile loaded in from the API itself if there's something wrong with it. So this is just a collection of all the talents and all their prerequisites here. And we have one for each of the specializations. Next up, we have the Warcraft log services. So this is how we connect to the Warcraft log API. So we have the URL here. And then I had to actually get a specific API key to actually use the Warcraft log API. We have our constructor here, where we register the HTTP client, or instantiate it, excuse me. And then we have our API methods, so our GET requests. So we have one for GET rankings, and we have one for getting kills logged, and then we also have one for getting the all-star points here. And inside, you'll notice I have a few filters for each. So finally, we have our talent profile service. So in this class, very similar to the Warcraft logs API, I have my custom API that I created here. And we have our properties. So initially I intended this to be used for multiple profiles, but due to an error or a bug that is known by Microsoft, the on-page navigation method isn't working. So it made it exceedingly difficult to implement the multi-talent profile feature. So once that bug is fixed, I plan on implementing it in the future. So we have our API method here, where we have our get talent profile method, and we also have our update talent profile method here as well. So as you can see here, in order to update the profile, I have to convert my talent profile into a talent DTO and then send it to the API. And similarly, when I receive talent profiles, I need to take that DTO and then convert it into a talent profile option. Great. So let's talk a little bit now about the XAML code here. So I'll only go over one of them, since a lot of the code is fairly repetitive. We'll head into the Holy Talents page XAML code. So looking at this here, we have this shell.title view. And so what this object represents is this header area of the application here. Next up, we have our content resources. So essentially what this is I'm loading in some of my custom converters I did to create some of the changes used throughout the application. Next up, we have our grid that represents the rest of this inner body of the application here. And let's go to the Holy Talent page in particular, because that's the one we're looking at. I could have done this in a collection view, however, and save myself a lot of lines of coding writing. But in order to get the specific shape of this grid, I had to individually hard-code each item. So it was a little bit more work, but the end result was very rewarding. So as you can see here, I have each of the buttons, so each of these things, data bound to a command that's declared inside of the view model here. And you can see that we have our add talent flag and our converter. And that just shows us different, so for this one actually in particular, it shows us this little border based on the flag in the code. And yeah, I have another data binding down here that is related to the current rank of the object, so that way when I click this button here, oh sorry, I have to add the plus mode, it updates the rank out of the total dynamically that way. And you can see we have the talents collection dot description, talents collection dot display icon path, so the icon we see displayed, and then we also have the current rank values. And when we hover, the description. So that is in the tooltip properties.text here. All right. So for the final portion of the application that I'm going to go through today, we're going to take a look at the view model classes. So the view model classes are really cool. So what I had done is I tried to make these as polymorphic as possible, essentially. So we have, each of our pages unique view models here, and the code isn't very broad. And the reason why is because we actually inherit from this base talent view model class. So once we navigate to this base talent view model class here, you see we have all of these shared features between each of these classes, which makes it really easy to implement a new talent class if we wanted to add more options for new talents in the future. So I'll just open some of these up so we can get a look at some of the variables that we're using behind the scenes in the code. Here I use observable properties to update a lot of the values you see visually on the screen, but we actually have an observable collection of talent objects, and that's how we're able to dynamically see the changes that happen through the user interface. So for instance, when a talent is clicked, we're able to see the change in the description. So down here we have our relay commands. So before I mentioned we had a command for when the flag changes. We have our modifying talent relay command. And so this talent here occurs whenever each talent is clicked, and then there's some conditional logic based on whether it is a true, so they are adding, or they're not adding. So it'll either increment all the counts used throughout the application and the talent profiles, or decrement them. We also have our relay command for clearing the talents, so this button right here. So when I click X, it just clears the content page and updates the totals dynamically. So I'm just going to go ahead over here, update this real quick. Awesome. I guess it was already at the 0 value, so that's great. So when we go over to our next area, we have our void/action methods. So we have a couple of methods that are used inside of these relay commands here, and I have them all encapsulated in this section of the application here. So we have a method to load the talents, and so this is used on the application page load. This is used to just make sure that all the talents that we see on the screen are correct, and also clears any bad values out of the dictionary, or resets the dictionary, or so to speak. We have our increment talents method that I mentioned before. We have our decrement talents method, our modify profile talents method, and yeah, that's it for the void methods there. I'll move on to the next section of the application here. So what I wanted to do to make my application really readable is that I encapsulated all of my Boolean expressions into cute little Boolean methods. And this just makes it so that way the code up here in my modify talent rank command, relay command, isn't so difficult to read. When I had originally designed this, there was a lot of code, very long, and it took up many lines. So by encapsulating it this way, it just made it a much more easy experience for me to go ahead and refactor my code. Because if I wanted to change a condition, it was as easy as finding the condition that I was looking for and just changing its value here directly. So next, we also have these cool property changed events. So inside of the base talent view model, we only have one, but if you remember inside of the the one class I showed you earlier, the talent class, any type of, or any property that is an observable property, we can add this onChanged method to. And essentially what we do here is we update all of the total counts for the specializations, equaling the page value of the specialization count. And then this is used in conditional logic to show the icon colors and allow an icon to be clickable. So for instance, when we have our prerequisites filled up, the icon color will change. Alright, and so the final thing that I think I'll go over through in this demonstration is actually the view code behind itself. So I'll head on over there to the Holy Talents page. Excellent. So in this area here, we instantiate the binding context by adding the view model to it. So this is what allows us to add the bindings to the XAML code. And I actually created this delegate event here. And essentially what I wanted to do here was to, load the talents from the talent profile into the application. And I deregister the event once the page is destroyed. But unfortunately, right now, this method isn't quite working as anticipated, and it's because the on-appearing methods and on-navigated-to methods aren't properly working with the MAUI shell. So there's a few things that I had wished to implement with the or wish that I would have been able to implement with the profile settings, but was unable to because of this current bug here, which I think is known by Microsoft. And I'll just show you really quickly in the base talent view model. There's a link to it right down here at the bottom. And so this code is also related to the customly invoked events that I created there. All right, and so I think that's it for my presentation today. I tried to keep it a little bit more condensed since there was a lot of repeating content and subjects, but I really appreciate everyone taking the time to watch this video, and hopefully you'll see more videos from me soon. Thanks.